Hello again. So I'm going to continue on this video about that introduction to mass spring oscillator, and this is the second example, which is to find so we need to find a synchronous solution that is in this form, and of course here we have a forced oscillation in this example. Let's say 2t, so that makes omega 2. Okay, so we can do, so that gives us y to be a cosine omega t plus b sine omega t, and we can use the 2. So I think probably it's better for you, since you know 2, you put it there and you just work with it, it'll be easier. But to match a little bit the textbook example, or a lot of examples, omega stays until the end. So I'll just keep omega for now. And so the next step is just to substitute the derivative into the equation, so it looks like I need all of them. Alright, chain rule. Second derivative. Again, just chain rule involved. Substitute in equation. It is the second one. And here is in the first one. And here is with the function. Alright. So once you do this, you know the next step. The next step is to distribute, stretch out this thing, and collect like terms. So I have a cosine omega, and I have a cosine omega t, or cosine omega. It's just I'm doing this just as if I'm talking to myself. That's how I do them. You just kind of recognize that you have a bunch of cosine omega t and its factors, and then you're gonna collect them, right? Then you're gonna collect the sine omega t, then that will okay. Let's see if we can clean this out. Alright, so if you pause the video and multiply and all that, Now you're going to check if you got this. After you have all the cosine omega t, factor cosine omega t, and you should have these. And after you have all the sine omega t, factor sine omega t, you will have these. Okay. And the right hand side, let's put, because we're gonna use matching, let's put, this is what I have on the right hand side. I don't have cosine omega t, so I'll put it there and I'll put 0, which means this. Okay, so if you watched the previous video, you know we're gonna match, just like if you did with partial fraction decomposition, and you're going to equal these coefficients. So this is 0, right? And this is 4. Okay. Now I think I'll just go ahead and use the 2. So if you did with the 2, now you should match with me here at this stage. Alright, so this is going to be bs a over 6, and this negative 6a minus b is 4, and now I'm going to use this here. Okay, then I will get negative 6a minus a over 6 equal 4. So common denominator will give negative 37a over 6 equal 4. So a is negative 24 over 37. We'll take it back to this, and now b is going to be negative 24 over 37 times 1/6. 24, negative 24 divided by 6, negative 4 over 37. Alright, so now we found a and b, so we can just put them in the given solution here. And omega is 2. So as you see in this example, we have everything. Okay, thank you.